Hi, welcome to Stoichiometry. This is going to be limiting reactions, and I'm Ms. Bedrosian, and this is going to be the simplest way that you can do limiting reactions ever that you will ever see. So limiting reactions is when there are two data sets. They give you two amounts, but only one set will be true, the other will be a lie. And it's up to you to determine which set is true, which data set that they give you is true. And the one that is false is the one that you're going to have to determine. Let's go right to an example. So you have 1.37 moles of nitrogen gas reacts with 1.63 moles of hydrogen gas. How many moles of ammonia are made? We're going, if you watch my previous video, follow along, skip 3 lines, write the balanced equation. You should be able to do this. Now put a hat on it, which is just a line right above the balanced equation. I call it a hat. So you put a hat on it. There's the hat. And on the left-hand side, you will write grams, skip a line, write moles. Moles are resting on the brim of the hat. This is where you put your data. Now we're going to put our data from the question in here. 1.37 moles nitrogen, 1.63 moles hydrogen, and X moles for the ammonia. That's what we are solving for, X moles for the ammonia. Now we're going to do our ratios, but now we have two different sets. Only one of these is true. The other is a lie. That means as the reaction goes along, one gets used up before the other. So you're going to set up your ratios as if the other one didn't exist. So we're going to do our two ratios. We're going to do this twice. 1.37 moles nitrogen gas over on the brim of the hat, 1 mole of nitrogen gas, that you get that from the balanced equation, equals, it must be an equal sign, X moles NH3 over 2 moles NH3. What's on the bottom is the bottom of the under the hat. Solve for this, and you get 2.74 moles NH3. Now we're going to pretend that we didn't get anything for N2. We're going to do the other one, H2. So we have 1.63 moles of H2 over 3 moles of H2 from the balanced equation equals, not multiply, equals X moles NH3 over 2 moles NH3. It's the same thing. And that will give us a different number. This comes out to be equal to 1.09 moles NH3. You can see this is lower. So what this is telling us, as the reaction chugs along, the H2 gets used up when we make 1.09 moles NH3. So as soon as we made that much NH3, there's no more hydrogen left. It's gone. We've used it. That's the most that can be made. This is the truth. This is all that can be made. We can't make any more because the hydrogen is gone. So the smaller number wins. This is the truth, because this tells us that that reactant is used up when we hit this amount. So the other one is the lie. That cannot be true. We can't make that much because we're going to run out of hydrogen before we get there. So hydrogen is the limiting reactant. A couple of things you always have to keep in mind when you're doing this. This is a double star. If the question gives you data in grams, change to moles first. If you recall from the first video, we did it, put it in grams, and we made a little arrow, change it to moles. Always solve for X moles. And then at the end, change it into grams if the question asks you in grams. Almost all the questions in chemistry will come to you in grams because there's no mole machine in the lab. Remember, the smaller number is the truth, the larger number is the lie.